This is the second part of the Keeping It Fresh Chapter 11 video. So let's get started at number 9. It says state what property is demonstrated. So we have 6 plus the quantity 4 plus x equals the quantity 6 plus 4 plus x. So if you look, the order of the numbers and variables didn't change, but the grouping did. The parentheses are around different objects. Remember, that means the associative property. There's 2 of those. One for addition, one for multiplication. So make sure that you state that this is the associative property of addition. Number 10, we have 3 times 4 times 5 equals 5 times 3 times 4. So if I look, they are the same numbers, but they're in a different order. The property that allows me to change the order of addends or factors would be the commutative property. Again, that has 2, a property for addition and a property for multiplication, so make sure that you say that this is the commutative property of multiplication. On number 11 and 12, we need to simplify the expression. That means you want to look for like terms. If it's possible to distribute, you want to distribute. I should have said that first because that's actually what you should do first, is distribute, then look for like terms. So if we look at number 11, we've got 2 times the quantity 6 plus 3n minus 4. Remember, it says simplify because I can't actually solve. I don't see an equal sign. You can simplify expressions. You can solve equations. So I can distribute 2 times both of these terms inside the parentheses. Distribute means I'm going to multiply. So 2 times 6 would give me 12. 2 times 3n would give me 6n. I rewrite that plus sign that was in between, and I'm going to rewrite this minus 4 that was outside there. Now I want to look to see if there's any like terms after I've distributed. So I see constants. I see a 12. And remember, you need to look at the sign in front of the term and a minus 4. So 12 minus 4 would be 8. There is no like term for the 6n, so that's just going to stay 6n. This is your answer. Expressions, when you simplify, sometimes might have variables or more than one term as your answer, and in this case we do. So our answer is 8 plus 6n. In number 12, we have 5a plus 7 minus 3a minus 2. I checked to look, but there is no distributing to do, so I just need to look for like terms. So I just start from left to right. So, okay, I have a 5a. I'm going to look for any other terms that have that same variable. So a, I need to include that operation sign in front of it, so minus 3a. And then I see I have some constants here, plus 7 and minus 2. Remember, if it's helpful for you, you can rewrite the problem so that the like terms are right next to each other. Just make sure, again, that you include the operation sign. So I can write it as 5a minus 3a plus 7 minus 2. So then 5a minus 3a is 2a, 7 minus 2 is 5, and there was a plus sign here, so plus 5. So the answer to our expression, the simplified version, is 2a plus 5. Now we're moving on to chapter 4. So it says find the area of the shape to the right. The key would be understanding what the name of that shape is. That's a parallelogram. If you forget your area formulas, not only can you go to chapter 4 in your book, but you also can go to the very last 2 pages in your book, have a reference sheet. There's a lot of useful information back there, including area and perimeter formulas for a lot of our shapes. So the area formula for a parallelogram is base times height. Remember, base and height always have to form a 90-degree angle, which is why they show these 2 dimensions forming a 90-degree angle here. If they'd given us a dimension for the slanted side, we wouldn't want to use it because it doesn't make a 90-degree angle with the base. So I want to multiply 20 times 7. I actually put the height here in the base here, but that doesn't matter because of the commutative property of multiplication. So 20 times 7 is 140. Your units are inches squared. Remember, area is always units squared. 14 says find the area of this shape to the right. This is what we call a composite shape. It means it's composed of 2 or more shapes that we know how to find the area of. I don't know how to find the area of this strange looking shape here, but they've even given us a hint with the dotted line to break it up into this rectangle and this. Maybe it's a rectangle, maybe it's a square. We'll have to do some figuring out to decide that. So let's start with this big rectangle here that I'm going to trace over in purple. Rectangles and squares both have the same area formula, which is base times height again, just like the parallelogram. So what are the base and height of this rectangle? Remember, they have to form a 90-degree angle. Well, I've got 4 would be here. It would be the same down here. I know sometimes we get confused because you think base always has to be on the bottom. So this would be a 4 down here if you were looking here. And this would be my height. So my base and height of that rectangle are 4 and 3. So 4 times 3 is 12. Let's look at that smaller shape. Well, I've got this dimension 2, so that means this also down here would be 2. So that's like my base. But how can I figure out my height? Both this and this would be considered my height. Well, they gave me this 1 over here. So I know that from here to here is 1. So how could I figure out the rest of this? Well, this full dimension here is 3. So that means all the way from here to here should be 3, and this part's 1. So that means this dimension right here needs to be 3 minus 1, or 2. So it turns out that this is a square because all the sides are the same. So the area of this shape, I would do 2 times 2, and that would give me 4. Then remember composite shapes, when you find the area of each piece of your composite shape, you need to add those together. So I would take 12 and 4 and add those together to get 16. Units on everything was inches, so that's inches squared for our final answer. 15 says find the area of the polygon with the given vertices, and then they give us 4 ordered pairs. So the first thing you should do would be to plot those ordered pairs on your coordinate grid there. We have 1, 1. So remember, in ordered pairs, the first number is your x-coordinate, the second number is your y-coordinate, just like the alphabet. Think about like the man that walks over to the elevator, and then he gets to go up or down, okay? So from the middle here, I want to go over to 1 first and then up to positive 1. So there's my h. I is 1, 6, so over to 1 and up to, this would be 6. Here's 5. It's not labeled, but your common sense can tell you that the next line up should be 6. Same thing over here. Here's 5, so the next line would be 6. So 1, 6, here's your I. J is 4, 6, so over to 4 and up to 6. And K is 4, 1, so over to 4 and up to 1. It says find the area of the polygon. So connect those lines to make a polygon. So the polygon that's created is a rectangle. We just said in that other problem that the area of a rectangle is base times height. So that means I need to figure out the length, the base and height of that rectangle there. Remember, to figure out how long, like this side is IH, or how long this side is HK, count the number of boxes long that it is. Don't count grid lines, count boxes. So if I count, there are 1, 2, 3, 4, 5 boxes going from I to H, so that means this distance is 5. Going from H to K, I see 1, 2, 3 boxes. So it's 5 units by 3 units long, so I'm going to multiply those together. So that gives me an area of 15. Now when you're dealing with a shape on the coordinate grid, I don't know how long those boxes are, inches, feet, centimeters, who knows? So we're just going to say units to the second power. We're moving on to chapter 7 questions, equation solving and inequalities. Number 16 says x minus 19 equals 52. Our directions are to solve that equation. So remember, the key with solving equations is opposite operations and doing the same thing to both sides to isolate the variable. So the opposite of subtracting 19 would be to add 19. So I'm going to draw my line where that equal sign is. I'm going to add 19 to both sides. Doing that makes these cancel out, so I isolate the x, that's what I want. And then I just need to do the addition here. So 2 plus 9 would give me 11, carry the 1. So x equals 71. Remember, it's really easy to check equation to see if you solve them correctly or not. Take your value that you got for the variable, so 71 in this case, plug it back in for x and see, does 71 minus 19 equals 52? Yes, it does, so then we did that correctly. 17, 4y equals 56. So 4y means 4 times y. So the opposite operation of multiplying would be to divide by 4. So that leaves me with just a 1y. Then I just need to figure out what 56 divided by 4 is. It's 14. So y equals 14. 18. Little green line is kind of getting in our way there. It's just trying to tell me that I spelled things wrong. So we have m over 7 equals 14. Remember, Written like a fraction, that means division. So this is really saying n divided by 7 equals 14. So the opposite operation of dividing is to multiply. I use the dot so that we don't get confused with an x like a variable. We've talked about how it looks like maybe that wouldn't cancel out, but it's just because we're writing it vertically instead of horizontally. So really that does cancel out that 7 denominator, leaving us with just m over here. And then we need to figure out what 14 times 7 is. It's 98. And then 19, p plus 17 equals 35. So I want to use opposite operations again. The opposite of adding is to subtract, so subtract 17 from both sides. Those cancel out to give me p. Here I'll need to subtract. And that gives me that p equals 18. Some more chapter 7. Inequalities was the other half of chapter 7. So remember, inequalities we solve the same way as we solve equations. You have to use opposite operations. You want to isolate the variable. You want to do the same things to both sides. Sides are separated by your inequality sign. Okay? So I have 10 plus c is greater than or equal to 11. So draw that line where your inequality sign is. The opposite of adding would be to subtract. That cancels out, so over here I just have a c. The inequality sign is going to stay facing the same way that it was, and 11 minus 10 is 1. So in words, I would read that as c is greater than or equal to 1. Remember, with graphing inequalities, you need to think about what kind of dot to use, and you need to think about which way to shade. We have either open dots or closed dots, which just means they're colored in. Open dots we use for just the less than sign and just the greater than sign. Closed dots we use for less than or equal to or greater than or equal to. An open dot indicates that that number itself isn't a solution to the inequality. A closed dot indicates that it is. Same thing with the line underneath. Okay? So since I see that I have a greater than or equal to sign, that means I want a closed dot on the number that's a part of my solution, not my original problem. So I'm going to put that number that's part of my solution in the middle. I'm going to fill in a few numbers to the right and a few numbers to the left. Remember, it's like a normal horizontal number line, so numbers should get bigger as you move to the right and smaller as you move to the left. You want a closed dot there on 1. But now I need to know where to shade. Where I shade means it's all the other values of c that would make this inequality work. So what other numbers are greater than or equal to 1? Are they the numbers to the left here of the dot, 0 and -1, or are they numbers to the right, 2, 3, etc.? Well, if you think about it, 2 is greater than 1, 3 is greater than 1. If I put in 0 for c, 0 is not greater than 1, -1 is not greater than 1. So I want to be shading to the right. Now there's also a trick. The trick is if the variable's on the left, and this only works when the variable's on the left, then that inequality sign kind of looks like the tip of an arrow that's pointing in the direction we should shade. Looks like it's pointing to the right, and we shade to the right. But that only works when your variable comes first, inequality sign, and then number. All right, let's look at 21. Solve and graph the inequality x divided by 4 is greater than 5. So use your opposite operations. The opposite of dividing would be to multiply. That cancels out to give you x. Inequality sign stays the same. 5 times 4 is 20. So put 20 here in the middle. Fill in a few numbers to the right and to the left. What kind of dot do we want to use here? Well, it's just greater than, so that means I want an open dot on 20. Which way do I want to shade? Read it in words, and that will help you figure it out. X is greater than 20. Where are the numbers greater than 20? They're to the right of that dot. Or use the trick. That looks like an arrow that's pointing to the right. Tell whether the value of the variable is a solution of the inequality. So in these problems, there's a little semicolon that's helping you distinguish where's the inequality and where's the possible solution. So this part here, x plus 3 is greater than 12, and then semicolon, that's the inequality. This is the potential solution. So solution, I don't know, we'll find out. So the way you're going to test is you're going to put that 5 in for x into this inequality. So I'm going to have 5 plus 3 is greater than 12. I like to put a question mark next to it because we're trying to figure out, is that going to be a true inequality or not? So simplify the side that has adding, subtracting, multiplying, dividing to do, okay? So here, 5 plus 3, I can add those together to get 8. Now I just have a single number on both sides. So now I can decide, is this inequality true? Read it in words, and that might help you. 8 is greater than 12. Is that true? No, it's not. 8's not greater than 12. So my answer here is no. X equals 5 is not a solution to that inequality. 23, you have n divided by 6. Might be a little hard to tell in the video here, but on your sheet it should be clear. That's an n divided by 6 is less than or equal to 4. We're testing to see if n equals 2 is a potential solution of that inequality. So again, I want to put 2 in for n. So 2 divided by 6 is less than or equal to 4. 2 divided by 6, think carefully about this. If I were to write that like fraction-wise, this is what it looks like. 2 is on the top, 6 is on the bottom. It's not 6 divided by 2. It's not 3. I could divide those both by 2 to get 1/3, but not 3. Okay, so be careful with that. So this simplifies to 1/3. If I read that in words, I'm asking myself, is 1/3 less than or equal to 4? Yes, it is. So my answer here would be yes. N equals 2 is a solution of that inequality. Write the word sentence as an inequality, solve, then graph. This is 3 steps. Writing, and then I gotta solve it. What you're graphing is the solution, not the original inequality. Some people made that mistake on the last KIF. So it says a number k increased by 3 is at most 13. Work your way from left to right and try to write that inequality. Think about your keywords and write it out. So a number k means they're telling me what variable to use. Use k. Increased by is telling me I should be adding 3. Is at most, remember just is by itself would tell me equals. Is and then a phrase like at most, at least, no more than, that's telling me an inequality to use. This is one of those tricky ones. Think about that. It's at most 13. That's the biggest it can be. So it can be 13 or numbers less than 13. So that's actually telling you that this is less than 13. I've written the inequality. Now I gotta solve it. Remember, we did solving inequalities already in this KIF. It's the same as solving equations. Do the opposite operation to both sides. So subtract 3 from both sides. That leaves you with k is less than 10. That is what you want to graph. Step 3 now on our number line here. So put 10 somewhere in the middle-ish. Put a few numbers to the right and a few numbers to the left. Decide what kind of dot to use. That's just a less than sign, so I want an open dot. And if you read it in words, that's k is less than 10. So I want the numbers that are less than 10. If I use the trick, that looks like it's pointing to the left. 10 less than a number a is greater than 10. Ooh, tricky, because we got 10 in there twice. So be very careful here. So I have 10 less than. That's that really tricky phrasing, or especially if we just start to write down the 10 and then we think, ooh, less than means subtraction. We're going to get that wrong, because less than does mean subtraction, but it's that one tricky phrase where the order that these parts come in is opposite of the sentence. So normally I would write 10 minus a, but because it's less than, the part that comes after less than actually goes first, the part that comes before less than actually comes second. So it should be a minus 10, not 10 minus a. Is greater than, so that's telling me the inequality. Greater than, they use the very simple phrasing there, so it truly does just mean greater than, just like the sign's name, and 10. Now let's go ahead and solve. So we've written it. Let's solve it. So opposite operations, the opposite of subtracting 10 would be to add 10. So that means I'm going to get a is greater than, and 10 plus 10 is 20. So put 20 in the middle. Put some numbers to either side. Decide on your dot. That's just greater than, so I want an open dot on 20. And it's a is greater than 20. So I want to shade where the numbers are greater than 20. If you use the trick, it's like that's pointing to the right. All right, chapter 6. Put the numbers in order from least to greatest. Key here would be thinking about your number line. Remember, 0 is our comparison, doesn't have a sign, it's not positive, it's not negative. Numbers to the right of 0 on the number line are positive. As you move to the right, numbers are getting bigger. Numbers to the left of 0 on the number line are negative. As you move to the left, numbers are getting smaller. Ooh, I wrote too big here. So remember, and this is how some kids think about it with negative numbers, is that negative numbers are kind of like the opposite of positive numbers. So if you were to figure out which number is biggest with positive numbers, it's the reverse with negative. So here I would know 5 is bigger than 1, but over here, even though positive 5 would be bigger than 1, negative 1 is actually bigger than negative 5. It's further to the right on the number line, it's closer to 0. So when we put these numbers in order from least to greatest, I'm first looking for all my negative numbers, and then I'm trying to figure out of those negatives, which is the farthest away from 0. So I've got negative 2, negative 3, and negative 1. Negative 3 is the farthest away from 0, so that is the smallest. Then negative 2, then negative 1, 0, and 4. 27, same thing. Find your negatives first. So I've got negative 5, negative 6, and negative 1. Negative 6 would be the biggest, or not the biggest, the smallest. Then negative 5, negative 1, 1, and 7. Next section, find the absolute value. Absolute value, remember the definition of that is the distance from 0. Distance isn't negative. So I don't care if it's 5 away to the right of 0 or 5 away to the left of 0. Both negative 5 and positive 5 would have the same absolute value of 5. They are 5 units away from 0. The absolute value of 0, well, 0 isn't anything away from 0. So the answer here is 0. 29, the absolute value of negative 19 is positive 19. It's 19 units away to the left, but it's still just 19 units away. 30 is tricky because of that negative sign outside of the absolute value bars. So remember, think about this part first. The absolute value of negative 22, well, that's 22 units away from 0. But there's a negative sign on the outside here making it the opposite of my answer. So the answer is actually negative 22. That's how you can get a negative answer involving absolute value. You can have a negative sign outside of those bars. And finishing it up with chapter 11, adding, subtracting, multiplying, dividing with integers. So you have to remember your rules here. Looks like we have adding first there. So remember adding, if you have the same signs, you add, and you keep the sign. If you have different signs, you actually subtract and just pretend as if they were like positive numbers. But then you keep the sign, or use the sign, I should say, of the quote-unquote bigger number, meaning the number that has like the bigger absolute value. So we have different signs there for 31, negative 12 and 5. So it's like we would do 12 minus 5, because different signs means we should subtract. So I get 7. But now I need to decide, is it going to be positive 7 or negative 7? Well, it's going to be whatever I had more of. I had more negative than I did positive. Think about your counters. Once you got rid of the counters, you'd have more red counters than yellow here. So the bigger number, quote unquote, the bigger absolute value would be 12. So that means my answer's negative 7. We move on to subtraction for the next two problems. Subtracting, remember, is the same as, say it with me, adding the opposites. So you're going to change your problem first. You're going to write right over this by changing it to adding the opposite, and then you're going to follow one of these two adding rules, whatever it ends up happening to be. So 9 minus a negative 2 is going to become 9 plus, and then I'm going to make this the opposite, so positive 2. Oh, that's easy now. That's adding two positive numbers. So 9 plus 2, that's 11. 33. Remember, and this is another thing we talked about, with subtracting, adding, it's the same as adding the opposite. It's leave, change, opposite. In other words, that first number shouldn't change. So that's going to stay negative 4, and then this becomes plus. Since that was a positive 3, it's going to become negative 3. So it's like I have negative 4 plus negative 3. So check my adding rules. I'm adding same sign numbers. So same signs means I add and I keep the sign the same. So 4 plus 3 would be like 7, but they're negative, so it's going to be negative 7. Multiplying and dividing have the same rules, which is that if they have the same signs, so they're both positive or they're both negative, then your answer is going to be positive. If they have different signs, so one number is positive and one number is negative, then your answer is going to be negative. So let's look at 34. You multiply like normal, so you think about, well, what would 8 times 5 be? It's 40. And then I look, okay, different signs means it must be negative, so it's negative 40. 35, remember number next parentheses means multiplying. So I can think of this as like 3 times 4, well that'd be 12. Same signs, they're both negative, so that means this is a positive answer, positive 12. And then 27 divided by negative 3. Well, 27 divided by 3 would be 9. They're different signs, so that means it's negative, so negative 9. That's it for our KIF Chapter 11. Mother.